Hello, my name is Santiago Martinez, and today we're going to be reviewing problem 8 from exam 4. It's a proof, and we will be using different formulas and identities of such natures to use. You should be able to use these if you are given the sheet. I will note whatever ones we decide to use right off the bat. So first thing, you got to pick a side and you got to stick to a side to prove. So I'm going to pick to the left side. It seems a little easier to condense this into this, in my opinion. But you never know. This could be, the right side could be easier to prove. If you feel like it, go ahead and try to prove both sides. So right off the bat, let's write as what we know. So we'll write each property that we're going to use in red and do our work in gray. So going off right out of the first property that I see is we're going to use our regular identities. We're going to use identities, or reciprocal identities is a more proper term, for secant and cosecant, right? So that would turn to 1 over cosine minus 1 over sine. The second thing that I see right off the bat is going to be this cosine of x plus sine of negative x. We know that we can probably write this using one of our terms, and the specific one that I'm talking about is even and odd identities. The specific one I'll write out is an even odd identity for sine, so we'll write that down. Even and odd identities for sine. And this one states that if we have sine of negative theta will equal negative sine of theta. So let's write how this would actually affect our problem. So we should have cosine of x now minus sine of x over 1 cosine plus, is it plus or minus? Minus 1 sine. So in order, the next step to this is we're going to combine our common denominator. So we have to figure that out. So right off the bat, we're going to have to multiply sine to one side and cosine to one side. So we should get something such as this. We'll write it out. So cosine, this is the top, so this won't really be affected yet. Sine of x over sine over cosine times sine, and then cosine. Oh, my apologies. Didn't mean to flip off there. Minus still cosine. Nope, that's incorrect. Of x. Make sure to fill in your x values. I always forget to do this. It'll make it a little easier to see your terms, and it's just the proper way of doing things. It's a little hard and a little tedious, I know, but it's the right way to do it. And this will be the same base, right? Because all we did was we multiplied this way and this way to get the same bottom. So then we have cosine, and as you can see, we're going to end up with the same bottom, right? And now, using basic algebraic rules, we can combine these two. Cosine, this is the top, over sine x minus cosine x over cosine x times sine x. Next thing you want to do is you want to copy dot flip it. So we still have a good amount of room. So we'll write that down. Copy dot flip. So we'll have cosine of x minus sine of x over 1 times cosine of x times sine of x over sine of x minus cosine of x. And this, for me personally, is the most tricky part because it seems a little confusing. But in this situation, what could we do to make sure that these would cancel out, right? Because right now we have sine and cosine. And that's not really what we want in this situation because it's negative cosine. So what we can do is factor out a negative, right? So we have cosine of x minus sine of x over 1 times cosine of x sine of x negative, and this in return will give us a positive cosine of x, and this is just going to be rewritten to the form, but it would first be the other way around, negative sine plus cosine of x, but in this situation we can now rewrite it as sine of x, right? We factor that out, and then these two can cancel out, and then we just multiply across. So if we multiply across, we should get cosine of x over sine of x over, forgot my s there, negative 1. And what does that turn into? Negative cosine of x times sine of x, and oh, that's just what it is, right? Because 1 over something is over, it is 1, something over 1 is just itself, and then obviously it's a negative, so we carry the negative with us, proving our answer. And the biggest thing here is just don't, this is part's tricky, don't forget to factor, or don't be scared to factor. I know it stumped me up the first time I did this problem because I was like, I analyzed it from a point of like, oh, I can't factor when I'm trying to cancel things out, when you really could. There's nothing saying that you can't. So you just got to make sure you know the algebra behind it. So yeah, that's how you do problem 8. Thank you.